Assalamu alaikum students. This is our next chapter, a video on forces and shapes. Recently, two videos related to Newton's laws are uploaded, and you must have watched them. Now, this is another video of forces and shape. In this video, you will learn what force can do, what are the effects of force. You will study about how force changes the shape. It causes body to accelerate or decelerate. So here, what is a force? It is a push or pull. It means behind every type of motion, the reason is a force. A force must be acting on a body, which will cause a body to move, change the speed, slow down, change the direction of motion. Everything which occurs during the motion of the body is due to that force. So force can cause an object to speed up, slow down, change direction, and change shape. Force is measured in Newton, and force is measured with a Newton meter. Okay, so this figure is Newton meter. There are some types of forces here. One very common force is the gravitational force, which makes a body's weight. This is the force which gravity exerts on the masses. So this force also exists between all the masses actually. All masses attract each other, but meanwhile, like in this video, we will talk about the gravitational force, the force which is caused by Earth. Okay, so if the masses are greater, the force will also be greater. So weight is the gravitational force of the Earth on an object. Okay, so gravitational force of the Earth on an object is the weight of the body. Okay, this is another type of force, normal reaction or contact force. This force acts when a body is in contact with the other body. Okay, and this is the actually repulsive force that stops two bodies touching bodies into each other. Okay, so normal means that the force acts at 90 degree to the surface of the bodies. Here the diagram is showing normal forces at the point of contact. This car is in contact with the ground where it has wheels. Okay, some of these two normal contact forces will be equal to the weight if this is in equilibrium. Under equilibrium condition, the two forces will be equal to each other. It means total normal contact force, this one R1 and R2, you may call it T1 or T2, yeah, N1 or N2, so that will be equal to body's weight. Third force, the friction. This is the force that opposes the motion of the body, and the kinetic energy of the moving object is converted into heat energy by the force of friction. So it means when a ball which falls through the air, it experiences uh, air friction, and it may slow down and it may reach terminal velocity. Okay, so it means this is in motion, its potential energy is changing but kinetic energy is not increasing. Means where is that decrease in the potential energy going? That is appearing in the form of heat here. So there are several two figures shown here. It is helpful for walking. Of course, it provides a proper grip, and you must have watched the video, that is the Newton's third law of motion, and that force which causes you to move forward, it appears only when your feet have the proper grip on the ground. Okay, and in the same way it is needed for the racing car to grip the road. Air resistance or drag force. This is the force that opposes the movement of the object through air. Okay, so drag is more general term used for the opposition force in any gas or liquid. So in order to minimize the drag force, the cars have streamlined bodies. Okay, so that will reduce the air resistance or the drag force. The front of this car is having a streamlined shaped. In the same way, sometimes we need to increase that air drag especially when we fall through the air using a parachute. Here, this parachute increases the surface area, so the drag force increases. Upthrust. So that drag force is due to the movement of air, movement of a body through the liquid or the gas. And upthrust is another force when the objects are placed in a liquid or a gas fluid. Okay, an object will float on a liquid if the upthrust force equals its weight. Okay, so hot air balloon rises when the upthrust from the surrounding air is greater than the balloon's weight, so it will move upward. Magnetic force, it is between the magnets, and it may be between the like it may be attractive or repulsive, like poles repel each other, unlike poles attract each other. And due to this force we can make electric motor work, and due to this force we can produce electricity. Electrostatic force, this is also attractive and repulsive in nature, means the charged bodies may attract each other or repel each other. Like charges repel and unlike charges attract. So this is the force between the two charged bodies. Now there is a series of blanks to be filled in. So you have to choose the appropriate word to fill up these gaps from the following. Okay, so what comes in each blank, you have to choose it from the words given here. Select the appropriate word and fill them up. Vectors and scalars. Okay, so all vectors are the quantities which need direction as well as magnitude. Okay, so direction has to be mentioned for the physical quantity to be more clear. Okay, so speed is a scalar quantity because we don't need direction. Force is a vector quantity because it has a direction. Of course, weight is a force and weight acts vertically downward. Force may act in the forward direction, backward direction, eastward, northward. Okay, so the force is a vector quantity, velocity, acceleration, they all are vector quantities. Okay, so they have direction to be mentioned. Scalars, they do not need direction to be mentioned. Distance, mass, time, energy, etc., they all are scalar quantities. We won't be studying much more detail about the vectors. Here we will be just studying few points about the vectors because our main objective of this video is to study about the effects of force. Okay, so we will study about the shapes in this video. So we'll just have a brief discussion related to the resultant of the two vectors here. This is the displacement vector towards east, and this is the displacement vector 25 45 degree north of east. Vector is represented by drawing a line with an arrow, and the length of the line tells you the magnitude and arrow tells the direction. Okay, resultant force, when number of forces act on the body, the combined effect of those forces is the resultant. So here both the forces are acting in the same direction, 3 and 2, so resultant will be 5. Here you have to find out the resultant yourself. There are number of forces given acting on a body, so you will work out the resultant and you also find out in which direction that resultant works. And you have some summary of the resultant force and what is the effect of that force on a body. If the resultant force acting on a body is 0, means forward force is equal to backward force, or all the forces are equal and opposite to each other, the resultant force will be 0. And what will be the effect? Object remains at rest if it is at rest, or it will continue its uniform motion in a straight line. It will continue moving with the constant velocity if it was already in motion. when there is no resultant force acting on the body. What happens when the forward force is greater than the friction, which is the opposing force? It opposes the motion of the body, so object will accelerate. And when the forward force is less than the friction, so it means object will slow down. So when object slows down, what do we call it? Object decelerates. There are some examples of the forces. The box will move when the man's push force is greater than the friction force. Okay, here the plane will accelerate provided that the engine force is greater than the drag force. Two more examples, example 3 and example 4. The brakes exert a resultant force in the opposite direction to the car's motion, causing the car to decelerate. In the same way here, this is air track shown here. So this minimizes the friction. So once released, the glider, this is glider which is moving on the track, moves at a near constant velocity as it experiences a nearly zero horizontal resultant force. Okay, so it will move with the constant velocity if the resultant force is zero, means forward force, the force with which it was pushed, is equal to the backward force. Here again you have series of blanks and you have to choose appropriate word to fill up from the following. Okay, so a single force called dash force can be used to replace a dash of forces that act on a body. A single force called resultant. Okay, when number of forces act on a body, rest of the blanks you will fill up using these words. Now, changing shape. Force can change the shape of the object. Okay, stretching force, what will happen? The spring will be under tension. Okay, when this is stretching force, it will become longer. And squashing force, it will put the object under compression. Okay, it will cause the size to reduce, and here this will cause the size to increase. Tension, it will extend the spring and it will compress the spring. So both are the change in the shape, and of course in order to bring these changes, force is needed to act. So here this force is causing extension here, so this will be under tension. What will this tension force do? It tends to bring the body back to its normal shape. Okay, it will tend to regain its normal size and shape. Now there are some materials here, brittle materials, glass. They do not change the shape easily and they break quickly. Okay, we don't see any stretching in the glass when you apply the force. It soon snaps and breaks. And resilient materials do not break easily, like car tires are resilient. Now, stretching springs. So this is an experiment. You have to suspend the spring by means of stand and clamp, and you have to note down the initial position without suspending any weight. Okay, so this note down the initial position of this, and you can change the weight one by one. 1 Newton force means 100 gram for where mass is suspended. Okay, and you note down the extension. You may take the force up to 6 Newton. Okay, and do not go beyond this because this may cause it to cross the elastic limit, because every object can withstand certain maximum force. If you increase the force then that maximum force, the object may stretch permanently. So we say that the object has crossed its elastic limit. So here there are some typical results. So you can fill up further. Suppose initially when there was no weight hung in the holder, the position of the pointer was 2. It could be 0 also. Okay, so here it is 2, and when the weight of 1 Newton is added, the pointer position becomes 4. Means the spring has extended. Okay, it is stretched. So how much is the extension? You will subtract that initial position from the new position, right? So 4 minus 2 is 2. So this is extension. In the same way, again this will remain same, because initial position when there was no weight hanging, the position was 2. So when the weight is increased, of course, the extension will also increase. Now it becomes 6, means 6 minus 2 is 4, because of course the weight is doubled. So extension is also increased. In the same way, when you increase 3 Newton, so extension may become 6 centimeter. Okay, so fill up this and go up to 6 Newton force. And the graph will be plotted taking force along y-axis and extension along x-axis. You can do the other way around also, means you can take extension on y and force on x-axis. Okay, so here force and extension, and graph is a straight line. It means force is directly proportional to extension, and object has not crossed the elastic limit. Okay, so you have not suspended any weight beyond the tolerance of this spring. Okay, so whatever maximum extension is, that will come here according to this graph on x-axis and force on y-axis. So Hooke's law states that the extension of a spring force is proportional to the force used to stretch the spring. Means proportional means if the force is doubled, the extension is also doubled. So in simple words, you can say uh, load is directly proportional to extension. Okay, provided elastic limit is not crossed. And this line is actually a straight line. The graph which is plotted, it will give you a straight line that will be passing through the origin. Now there are some questions. A spring of original length 150 millimeter is extended by 30 millimeter force by a force of 4 Newton. Calculate the length of the spring if the force of 12 Newton is applied. So 12 Newton is 3 times greater than the force of 4 Newton. 4 Newton causes it to extend 30 millimeter. It means 12 Newton will cause it to extend by 30 into 3, means 90 millimeter. So new length will be what? The initial length was 150. So you will add the extension. What is extension due to that 12 Newton force? 90 millimeter. So new length is now 40 millimeter. Elastic limit. Up to a certain extension, if the force is removed, the spring will return to its original length. The spring is behaving elastically. Okay, elastically means it will return to its original length when you remove the force. If this critical extension is exceeded, known as the elastic limit, the spring will be permanently stretched. We say that it is distorted permanently, it has undergone permanent deformation. It means it will not return to its original length. Okay, and it means it won't be obeying Hooke's law any longer. Okay, because after the proportionality elastic limit is crossed, object will not obey Hooke's law, means load will no more be proportional to extension. Force against extension graph if the elastic limit is crossed. See, this is showing greater extension for smaller force. This curved line shows that it extends more than before. Okay, extension is greater for small increase in the force. This point here shows the elastic limit. Okay. Here, this is the diagram of an object which does not obey Hooke's law. This is rubber. Okay, elastic band does not obey Hooke's law, means the graph will not be a straight line. Okay, so load is not proportional to extension. Okay, it will stretch and it will come back to its original length when you remove all the forces. All the masses are removed, the rubber band will come back to its initial length, but the load and extension graph will never be a straight line for elastic band or a rubber band. Here now you again have some blanks to fill in. Hooke's law states that when a wire or spring is dashed, the increase in length or dash is proportional to the load dash applied. Let's see what comes. There are the words which are to be filled in here. So spring is stretched, the increase in length or extension is proportional to the load, yeah, force applied. This law is not obeyed if the spring is taken beyond its elastic limit, after which it will become permanently stretched. A rubber band does not obey Hooke's law. A graph illustrating Hooke's law will have a line that is straight and passes through the, of course, last word is origin. Here we have one more thing to discuss, and that thing is related to this graph. The graph, which is a straight line between force and extension. So if the graph is plotted here, the gradient of the graph will give you spring constant. Okay, and spring constant will tell you how much extension will be caused by 1 Newton force. Spring constant, if you calculate the gradient of this graph, gradient, you know how to calculate the gradient, change in y-axis upon change in x-axis. So any value may be taken here. Suppose this value is 4 Newton, and suppose this causes 8 centimeter extension. Okay, so what will be the gradient equal to? Y2 minus y1 over x2 minus x1. So gradient y2 minus y1 over x2 minus x1. So answer will be 4 divided by 8. So what will be the unit? 0.5 Newton per centimeter here. SI unit is Newton per meter. You could get this unit Newton per meter also if you had converted 8 centimeter into meter. This answer would be in Newton per meter. So this is called K, and this is spring constant or stiffness of the material. Spring constant or stiffness, constant of proportionality, and it comes from that Hooke's law, which says that force is directly proportional to extension. If you remove proportionality sign, we get equal sign and a constant K, X. So K is equal to F over X, that is spring constant or stiffness. Okay, and this depends upon the material. Beside this, this depends upon the shape of the object, geometry of the object also. So in the other video we will study what happens when two springs in series are joined and two springs in parallel are joined. What will be the extension produced? What will be the effect on the extension when you connect spring in what way, in series or in parallel? Okay, series means one after the other. This is one spring and you join one more spring, so this is two springs in series. And when you suspend mass, what will happen to the extension? So this will be studied in the next class, next video, and of course in the class. Allah Hafiz then.